today I will talk about understanding crime, inventions, and contagious disease in cities using the tools of mathematics. Cities are incredibly complex. How can we think about something as complex as cities? It turns out that we need a very particular type of thinking. Elon Musk actually summarized it pretty well. He claims to use it in his entrepreneurship with Tesla and SpaceX. He says, we often conduct our lives by thinking with analogy. That's what happened in the past will happen in the future. This may tell us what will happen, but it tells us very little about why things happen and to really generate an understanding. So instead, he advocates for what he calls reasoning from first principles. In his words, you boil things down to the most fundamental truth and reason up from there. So we start simple, we start with a few things we know for sure, and see if those things are enough to explain the complex world that we see. So this idea is at the core of my field, applied mathematics. Today, I will illustrate how we use this type of thinking to solve a mystery about cities. Okay. So I'd like to first walk you through this graph. There are about 300 metropolitan areas in the United States, and each one of them is represented as a marker on this graph. Horizontally, we're looking at population of each of the cities, from 10,000 to 10 million. So think Urbana, Illinois on the low end, New York City on the high end. Vertically, I'm showing the amount of patents, inventions produced in each cities. If we live in a world where we double the city population, we simply double the amount of inventions produced, I'm expecting to see this black line, which we'll call the linear world. However, the data we see from 300 US cities of drastically different sizes and in drastically different areas show this very simple relation that is steeper than this black line. It means when I double the city size, I more than double the amount of inventions produced. That is strange. What makes it more interesting is that it not only happens for inventions, but it happens for some other things that affect our lives. See, for example, I'm showing the number of robbery cases in those US cities, and here are the number of AIDS cases. So all these three quantities are serious issues that affect our everyday life. However, they seem totally not connected with each other, but they all follow this simple relation that suggests there may be some common ground among these three things. And we live in a world where when the city gets bigger, there's higher rates of all the three things, the positive and the negative. The first question I want to answer is why does city size has effect on all three variables? When I look at this problem more closely, I find something more intriguing. When I look at the crime data broken down into categories, here I'm looking at number of robbery and rape cases. Robbery, as you've seen before, is the one that shows city size effect, while rape, which is also a serious violent crime, shows a behavior that's completely different. It follows this black line, which means when cities get bigger, the chance of rape cases happening is almost constant. My second question is, why does this happen for some quantities but not others? So now I'll go through the procedure of thinking from ground up and try to answer both questions using one answer in mathematics. Okay. This is what we'll do. We will start with a few things we know for sure, and we'll translate them into math equations. Then I'll get a testable theory. In the end, I'll look into data from the real world and see if I get it right. So here are what we know for sure. There is extensive study in the social sciences that says there is a social nature in crimes, inventions, and contagious disease. I think that may be the common ground among all these three things. And in the study of social networks, this is one of the best studied results. That is, we have strong ties as well as weak ties. Because weak ties are distant to the core of our social network, they are actually the one that feeds in novel information to us. Those are the things that drive output, like finding a new job, starting a new business, or in some cases, find a partner in crime. So now I can translate this complex question about cities into solvable mathematical questions. The first one is I can estimate how many ties I would expect to have if I live in a city of a certain size. And among those ties, how likely I am to find all the partners I need for an activity. From that, I can estimate what's the output of this city. Those are all mathematically well-defined questions. After I generate my prediction, I now look into data and see if they agree. Here, I'm showing the robbery and rape cases data as we showed on the first slide. Robbery is the one that shows city size has an effect on its rate, while the number of rape cases doesn't. The red lines are what the theory predicts. They agree very well. What I like to highlight here, it is actually one same math equation that goes behind both of these pictures. Why can't one same equation explain both? It turns out the answer is robbery is often a group crime. The number of partners needed is higher, while rape is mostly a solo crime. If we take this idea a step further, this is what we'll see. If I look at the co-offending group size, whose data we gathered from the Chicago Police Department, and the amount of size effect each crime has with city size, those data come from the FBI crime report. We see this increasing relationship in data that the more people I need to conduct a crime, the higher the city size effect. That's seen in both the real world and in this theory's predictions. So it in turn confirms that the city size effect indeed comes from social interactions. So with that, I'd like to conclude. In this research, we generated new knowledge about cities. We were able to explain why some seemingly different variables have a city size effect by social networks. And the effect from social networks and these weak ties can also explain why does this happen for some quantities but not others. This research has a number of implications for policies. One of them that I like to highlight is how it affects we study crimes. Traditionally, we've been studying crime by looking at the property of people in a community, their race, their socioeconomic status, and so on. This is saying even if I had communities of identical people, the bigger one will inherently have a higher risk of group crimes. I hope this way of thinking will open new doors for crime research in the future. If there's one thing that I'd like you to take away from this talk, it is the type of thinking we use to reach these conclusions. That is to think from ground up, like Elon Musk says. I hope this type of thinking will also help you to solve your problems in everyday life. Start simple and start with what we know for sure. Thank you.